So before we get started, I wanted to go through some um, safety precautions with certain chemicals that are being used in this lab. Um, and they're also listed in your lab manual, but I wanted to bring those to your attention. And the reason for this is I know that we're not actually in lab, but because this is really the only time we're going to get this kind of exposure to this, it's just good to kind of reiterate these things for each lab, so that way it kind of stays more fresh in your head. So one of the things that you're going to be using is acetone. Acetone is a flammable and an irritant. Cyclohexane, it's highly flammable and also an irritant. Cyclohexene, also highly flammable and also an irritant. 2-ethanolic pyridinium bromide perbromide, that's a mouthful. Flammable, toxic, irritant, and also a lacrimator. And a lacrimator is something that makes you cry if exposed to your eyes. Also, 2% aqueous potassium permanganate, an oxidant and also an irritant. Toluene is a flammable and also toxic, and your unknowns are flammable, toxic, corrosive. They are irritating, oxidizing, and or carcinogenic. And I think we all know that carcinogenic means that is something that can cause cancer. So it's best that we don't expose that to our skin or ingest it or take really deep breaths of it. So I just wanted to bring that to y'all's attention. And also, too, guys, the PVP is also known to cause sterility in men. I thought that was interesting. So if you guys were to be doing this in lab, I would have asked that the men not handle that and only let the women handle it because it is completely safe for them. Anyway, so going forward. It's funny, Sean.
One is enough, trust me.
Where's the spot for like the unknown 3?
Spot for the pause What's this right here? Okay, yeah, so let me go to the lab manual real quick. Yeah, I think you're going to be getting 2 extra unknowns, so you're going to have to add those in, I believe. So yeah, you're going to have 2 extra unknowns. So you have unknowns 1, 2, and 3, and 4. So yeah, let's look at this here. So this is how it's actually going to change. I figured I'd wait till now to tell you guys this. So you're going to have a few changes in your lab manual, just as it shows. So toluene, or 1-octene. There's going to be xylene, canola oil, and then unknowns 1, 2, 3, and 4. You're going to have 5 knowns and then 4 unknowns. Cool. Okay, looks like everyone's written it down. And so in this step, you're going to be adding the PBP. For the PBP, what's going to be happening is it's going to be a halogenation of an alkene. In the lab, if we're doing it, you would actually make sure that this is a very well mixed reaction. So you'd want to swirl it really hard. And so what you're looking for is if there is a reaction and the bromine is able to react with the specific compound, you're going to be seeing that the original solution is actually a yellow-orange color. And as it's being used up, the mixture will actually turn colorless. And so you would compare that to your unreacted PVP, and you would see, okay, is this a saturated or unsaturated compound? Is it able to react or is it not able to react? And so you're going to be looking here, and as it's being added, you're going to write down, okay, is this still yellow, slightly yellow, or colorless? So let's go through. And also to make sure that you are recording the number of drops as well. It's not really holding it. Still looks a little yellow to me. And I would say too that if it is still at least a little yellow, I would say that this is a saturated compound.
How many drops was that on number 3?
Let's go back. I want to say 4 drops. Does that sound right to everyone else?
How much was this number 2?
I thought I saw
I
5.
put down 4.
Yeah, I saw 1 drop at first get stuck to the side, and then like 3 quick ones, and the last one like caught the 4th drop that was stuck on the side. That's what I saw.
And how many was in number 2?
Let's see, let's go back. Two or 3? I couldn't really tell. What do you guys think?
I saw 3 on that one.
Oh, 3. Okay, then
think
probably
3.
3. Okay.
Am I just blind, or is that last one, number 3, seems slightly yellow?
To me, it looks more clear between 3 and 1.
Okay.
So number 4 definitely looks yellow.
Wait, did we catch the drops for 4? Sorry.
Yeah, you should be just seeing that. I'm not gonna like say it every time, but we can go back real quick.
Sorry.
All right. So it looks like that wasn't a drop. So 1, 2, 2.
Thank you.
Mhm. And also too, if you guys see, so like for number 5, that like first like drop is not really a drop. It looked like it was just like a bubble at the end. So don't count that as a drop.
Is that a light yellow for 5?
I would say it's to me that looks clear, but I mean it looks a little foggy, like, but yeah, it's kind of hard to tell, right? Like I don't know. Look to me, I would say that's clear, but but that's your call. So that's definitely clear. So 8 and 9 definitely look yellow. Like 9 definitely looks yellow, but yeah, 8 and 5, man, they're like kind of tweeners, I guess. It's like slightly yellow. It could just be like the nature of the compound, but So here's adding 10 more drops to each one. And I'm assuming they're going to change, but we'll see.
This is still that first section, right? The PvP.
Yeah.
Okay.
So it's positive if it's clear, right?
Yeah.
You all right?
Okay, sorry. Let's go back a few steps. Okay. And so everything all right, Sean?
Yeah, the kid's making noises. I thought she was choking there for a second. Sorry.
Okay, well, hope everything's okay. Anyway, so now we're moving on to the potassium permanganate. And so with this reaction, this is an oxidation of an alkene. And so this is different from the first test. And your alkene that you have will not be miscible with the potassium permanganate. So the you have to dissolve them in acetone first, as it says here. And yeah, so let's go through. So this is our control tube. Can anyone tell me what the control tube is for?
Sort of look like during what it's supposed to do.
If it's a control, so it's not going to be what your reaction should look like, but it's a base. It's a negative control. So basically, it's to compare to see if there actually was a change or not. So again, going back through. And so what we're trying to see is it changed from a purple color to a mud, sort of like a mud look. So I'm guessing like a nasty like brown color. And that will tell you if your compound is indeed unsaturated. If it stays purple, then it is unsaturated. So what do you guys think? That still looks pretty purple, right?
Yeah.
Yeah.
So there is a slight color change, but I wouldn't call that necessarily a mud color.
Just dark purple.
That number 3 to me looks a little bit more like a mud color. I don't know that when I read that mud, I don't know exactly how dark it's supposed to turn. But I would say because there was a color change, I would say that it is unsaturated, at least for number 3. It's a pretty, but let's look at some other ones and let's kind of compare those two, because maybe those won't change at all. And then we can definitely say, okay, that's, so like this one right here, number 4 is definitely still purple. So I would say number 2 and 3 are unsaturated based on the color change, especially number 3. This one is colorless. Oh. Yeah, see if you compare number 4, number 5. Number 5 looks like there was a color change, not as much as number 3, but you know. So and I believe he's adding the compound, and then the acetone, and then the potassium permanganate. Yeah, so that one's still pretty, like, looks just like number one, right? Your control. So yeah, I would say number 2, number 3, and especially number 3. Obviously number 4 still looks very, very purple, right? Number 5, I would say, is unsaturated. Not quite as a deep as number 3, but number 6 would definitely say that's saturated. So negative.
Yeah, number 3 has definitely gotten darker while sitting there.
Yeah.
So hasn't number 5.
You said number 5 has or has not?
It has gotten darker.
Yeah. What about number A, D? I think it's saturated or unsaturated. Okay, so the solution should stay purple or have brown solids, making the solution murky. So I'm guessing this is when it becomes more of a mud color.
Two's almost reddish. It's so dark.
Yeah, it's not quite getting that muddy color, but there's
3 definitely is.
Yeah, oh yeah, 3 for sure. 3 and 5 are looking pretty dark. 7. So yeah, I would definitely say 3 and 7 definitely look like they're unsaturated. 8 and 2 and 5 are kind of, I don't know, like they're not really doing what he said they were going to do in terms of like what 3 and 7 are doing. Like turning like really, really brown, but
They're not turning brown, but if you look at the glass, it looks like there are like the solids that he was talking about.
yeah. Okay, yeah. Yeah, I see that. So yeah, so you could definitely look at that and consider it unsaturated for sure. And also comparing that to, you know, number 4 and number 9, and number 6, you know, those definitely you can tell are saturated. Yeah, for sure. So yeah, so that's the end of that. So does anyone have any questions about the data?
No.
Does
If
anyone
it's
wanna repeat what
negative,
drops numbers were for 8 and 9 on the first one?
On the first one, what do you mean the first one?
The reactions with the ethanolic pyridium.
Oh, so like way back?
Yeah, just for if someone has them written down. If not, I'll wait for the video to come back out. But
Okay, gotcha.
On which one?
8 and 9, the unknowns 3 and 4.
For 8, I put 2, and then on 9, I put 3.
Thanks.
or
Sorry?
is it purple negative or is it positive?
Say that one more time, I'm sorry.
If it was purple, it's negative or positive?
So if it stayed purple, it is negative. If it changed to the brown, or if it I think, what's her name, Christine? Yeah, she pointed out if it like had those like small solids on the side of the tube, then that is also considered positive. But if it stayed purple and there's none of those solids, it's negative. So if it looks just like number 1. And I just want to ask real quick, would we be able to move this Friday meeting to 1:30? Does anyone object to that at all? I mean, if not, I mean, if you do, it's fine. Like, don't feel bad or anything. I just, because I also teach at 3. I don't know why I booked them back to back. I didn't think that. I thought they'd all take like around half an hour. But also I want to be able to get more into things with you guys in terms of like the pre-lab stuff. So would you guys be able to do that?
Yeah, that's fine by me.
Yeah, that
Okay.
works.
I'm good with 1:30.
Okay, cool. So I'll also send out an email like sometime next week, like early next week, just to remind you guys, so that way we have more time to answer more questions. And Christine, so for the pre-lab, I know you guys turned that in. So just do the best you can, because yeah, I don't have a lot of time to go through it with you. But if you go to the lab manual, there are some examples. So just keep in mind that the bromine is just going to react with the 2 carbons across the double bond. So whatever you have there, as long as it has that, then it should be right. But if you're like adding carbons and stuff like that, then it's probably not right. Yeah. So, and remember, it doesn't react with aromatics. A fun fact is the aromatics actually work, and there's something that I want to tell you guys, but is that they actually call them that not because of any specific reason in terms of the double bonds. They actually found out about those things later on. They just called them that because they are aromas, and so you can smell them. So the whole pi bond and electron sharing came on later. So they're actually called aromatics because of the smell. So anyway, if nobody has any other questions, I'm going to stop sharing. So again, next week, 1:30, I will send out another link. I don't know if this one's still good, and I'll send out an email earlier in the week, and I'll let Dr. Irvin know, so that way he can have the video uploaded sooner. And yeah, everyone have a great weekend, okay?
Thank you.
All right,
Okay, guys.
You too.
Have a good one.
bye.